In this video, we're going to look at a few things to do with equivalent fractions. Now, this video should only be watched if you have already learnt something about equivalent fractions. Please start by doing these 3 questions. Pause the video while you do them. Press play once you're ready. You should have now done these 3 questions. I'm going to go through them. So for question 1, list the first 5 equivalent fractions equal to 1/5. So we can multiply top and bottom by 2. That gives us 2/10. We can multiply top and bottom by 3. That gives us 3/15. We can multiply top and bottom by 4. That gives us 4/20. And we can multiply top and bottom by 5. That gives us 5/25. For 2/3, we can multiply top and bottom by 2. That gives us 4/6. We can multiply top and bottom by 3. That gives us 6/9. We can multiply top and bottom by 4. That gives us 8/12. And we can multiply top and bottom by 5. That gives us 10/15. Now, to find the missing numbers, we need to say what has the numerator or denominator been multiplied by, and do the same to the other one. So here, the numerator has been multiplied by 3. So we need to multiply the denominator by 3 as well. 8 times 3 is 24. And for the next one, we have 4/7 equals something over 14. So what has 7 been multiplied by to get to 14? It's been multiplied by 2. So what do we need to multiply 4 by? We need to also multiply it by 2, and that makes 8. So 4/7 is the same as 8/14. Just to show you why equivalent fractions works, let's take the example of 1/4 being the same as 2/8. So why is that? Well, if I draw a circle and I split it into quarters, then I draw the same circle, but this time I split it into eighths. So the first circle I've split it into 4 equal parts. The second circle I've split it into 8 equal parts. It doesn't look like it, but that was the intent. And if I shade just one of those 4 parts, that looks like that. And if I shave 2 of the 8 parts, it's exactly the same piece. This piece of the circle here is exactly the same as this piece of the circle here. So 1/4 is the same as 2/8. And that works with every single other equivalent fraction that you could do. So the overall rule is that whatever you do to the top of the fraction, you do to the bottom as well. Please pause the video to mark and correct your work. Press play once you've done that. You should have now marked and corrected your work. So what we're going to do now is show that 2 fractions are equivalent. So that's a bit different from writing an equivalent fraction. What we're going to do here is say, okay, here are 2 fractions, show that they're equivalent. So the way we do that is we start with one of them. So I'm going to start with 2/7. And we show that both top and bottom have been multiplied by the same thing. So in this question, to get from 2 to 10, that's been multiplied by 5. To get from 7 to 35, that's also been multiplied by 5. So what we do is we write that this is times and then 5/5. What we're showing there is that we've multiplied the top by 5, we've multiplied the numerator by 5, and we've multiplied the denominator by 5. So that bit that I've done in red, that's the evidence that these 2 fractions are equivalent. I've shown that I'm multiplying both the numerator and denominator by the same number. Both the numerator and the denominator have been multiplied by 5. That shows that 2/7 and 10/35 are the same thing. Let's do this one together. Pause the video, have a go at showing that these 2 fractions are equivalent. Press play once you've done that. You should have now had a go at showing that these 2 fractions are equivalent. So the way we need to do it is we need to start with 11/10. We need to work out what has the numerator been multiplied by. So what has 11 been multiplied by to get to 88? Say your answer to the video. It's been multiplied by 8. And what has the denominator 10 been multiplied by to get to 80? Say your answer to the video. 10 has also been multiplied by 8. So what we show is that it's been multiplied by 8/8. So both the numerator and the denominator have been multiplied by 8 to make 88/80. And we've now shown that those 2 fractions are equivalent, meaning those 2 fractions are the same. I'm now going to do this example. So this is a bit different in that we first need to write down what the fractions are. So this circle has been split into 6 equal parts, so that goes on the denominator, and 2 of them are shaded. This has been split into 5, 6, 7, 8, 9, 10, 11, 12 equal parts, and 4 of them are shaded. Now I can see from the picture that the shaded parts look exactly the same size, but I need to now show, using my method, what have both top and bottom been multiplied by. So 2 has been multiplied by 2, and 6 has also been multiplied by 2. So that shows that those two fractions are equivalent because both the numerator and the denominator have been multiplied by the same thing. Remember, equivalent means the same. Pause the video to have a go at this one. Press play once you're ready. You should have now had a go at this one. So let's go through it. So how many pieces has this circle been split into? Say your answer to the video. You should have said 4. And how many of them are shaded? You should have said 3. Let's do the same with the other circle. How many pieces has this circle been split into? Say your answer to the video. You should have said 16. And how many are shaded? You should have said 12. But for the show that, we need to do 3/4. And what do we need to show that it's equivalent to 12 over 16? Say your answer to the video. We need to show that both top and bottom have been multiplied by the same thing. What have both top and bottom been multiplied by here? Say your answer to the video. Both top and bottom have been multiplied by 4. So we write times 4 over 4 equals 12 over 16. And that's now done. Pause the video to do these questions. Press play once you've done them. You should have now done these 2 questions. So let's quickly go through them. So this one has 5 parts, 4 of which are shaded. This one, I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 parts, and 12 of them are shaded. Then I need to show that 4/5, both top and bottom, has been multiplied by 3. Please be clear. I'm not multiplying 4/5 by 3. That's not what's happening. 4/5 is not being multiplied by 3 here. I'm just multiplying the numerator by 3 and the denominator by 3. Let's do the next one. So that's 1 over 2, and this one is 3 over 6. And then I show that 1 over 2 times 3 over 3, because both numerator and denominator have been multiplied by 3, equals 3 over 6. Pause the video to mark and correct your work. Press play once you're ready. You should have now marked and corrected your work. We're now going to try and find the missing value. So this is the same as normal equivalent fractions, except these are not perfect fractions. What is 1 2/10? What's that called? Say your answer to the video. It's called a mixed number. Now, we've got 1 2/10, and that's equal to 1 14 something. So the 1 is the same for both, so I don't need to worry about the 1 at all. So all I need to do is say, what's the 2 been multiplied by to make 14? It's been multiplied by 7, so I do the same to the denominator. 10 times 7 is 70. So 1 2/10 is the same as 1 14 over 70. The integers, the whole numbers, were the same in both fractions, so they didn't affect the question at all. Pause the video to have a go at this question. Press play once you're ready. So you should have had a go at this question now. So the idea is that the whole number 3 doesn't matter because both have the same whole number. So they're both 3 and something. So all we need to do is find out what did the 10 multiply by to make 110. Say your answer to the video. The 10 has been multiplied by 11. So this number up here must also have been multiplied by 11 to make 11. So what must that number have been if it's been multiplied by 11 and finished with 11? Say your answer to the video. That number must have been 1. So 1 times 11 is 11, 10 times 11 is 110. Both numerator and denominator have been multiplied by the same thing. So 3 1/10 is the same as 3 11 110ths. Pause the video to have a go at this one. Press play once you're ready. So you should have now had a go at this one. So we've got 2 3/4 equals 2 and something over 36. The whole numbers are the same, so they don't matter. What has the 4 been multiplied by to make 36? Say your answer to the video. The 4 has been multiplied by 9. So what do we need to do to the 3? We need to also multiply it by 9. What is 3 times 9? 27. So 2 3/4 is the same as 2 and 27 over 36. Pause the video to find the missing value in each of these questions. Press play once you've done that. You should have now done these 3 questions. So let's go through them. 2 over something equals 16 over 96. So the 2 has been multiplied by 8. So that means the number on the bottom must also have been multiplied by 8. What times 8 is 96? Must be 12, because 12 times 8 is 96. The next one, we've got 1 and 8/12 equals 1 and something over 24. So the 1 is the same in both cases, so we can ignore that. What has the 12 been multiplied by to make 24? It's been multiplied by 2. So the 8 must also be multiplied by 2 to make 16 over 24. And the last one, 1 and 8/9 equals 1 and something over 36. Well, the 1 in both cases is the same, so that doesn't make a difference. So we just have 8/9 and we need to find what that is over 36. So 9 times what is 36? Say your answer to the video. 9 times 4 is 36. So what do we need to do to the 8? We need to also multiply it by 4. What's 8 times 4? 32. So 1 and 8/9 is the same as 1 and 32 over 36. Pause the video to mark and correct your work. Press play once you're ready. You should have now marked and corrected your work. So let's move on. Writing an integer as a fraction. So here, we're going to write the integer 3 as a fraction. And the way to do this is to understand that a fraction is a division. So I've got some number up here, the numerator. I don't know what it is, but when I divide that number by 7, it equals 3. Remember, in a fraction, the top number, so let's say you had the fraction 10 over 2. What does that actually mean, 10 over 2? What does that mean? Does it mean 10 plus 2? Does it mean 10 minus 2? Does it mean 10 times 2? Does it mean 10 divided by 2? What does it mean? Say your answer to the video. 10 over 2 means 10 divided by 2. That's what fractions mean. It's the top number divided by the bottom number. It's the numerator divided by the denominator. So we've got some number that we don't know, divided by 7 makes 3. So what must that number be? Well, it's 21. If you know your times tables, you know that 21 divided by 7 is 3. Let's do this one. 3 equals something over 11. So I need to think, what divided by 11 equals 3? I know my times tables, it's 33. 33 over 11 is 3. So what this shows is you can actually write an integer as many different fractions. I could write the number 3 as 3 over 1, or 6 over 2, or 9 over 3, or even 300 over 100. Or I could even write it as 90,000 over 30,000. As long as the top number divided by the bottom number equals 3, those are correct fractions. It's now time for you to try. So pause the video to try these 3. So you're trying to find the missing number in each one. Press play once you've done that. So you should have now tried all 3. So let's go through them together. So we've got 3 equals something over 7. So we need to find what number when divided by 7 makes 3. So the answer is 21, because 21 divided by 7 is 3. Then we have something divided by 3 is 7. So that something is also 21. If 21 divided by 7 is 3, 21 divided by 3 is 7. And finally, something divided by 4 is 20. Something divided by 4 is 20. So I need to think, what, when you divide it by 4, makes 20? Now, this one might be a little bit trickier, but notice each time, if we just do this number multiplied by this number, it makes this number. So over here as well, if we did this number times this number, it makes 21. So let's do the same thing here. 20 times 4, that equals 80. Then we can quickly check, what's 80 divided by 4? So 4 into 80. So this is just me checking. Yep, that's right. 20 is 80 divided by 4. You're now going to try it yourself. So pause the video to do these questions. Press play once you've done them. You should have now done these questions, so let's go through them. So something over 5 equals 5. So something divided by 5 equals 5. So that something must be 25. 25 divided by 5 equals 5. So the answer is 25. The next one, 2 is something divided by 15. So what divided by 15 makes 2? Well, you could quickly work out that 2 times 15 is 30. So that means 30 divided by 15 equals 2. And finally, something divided by 3 equals 9. So what divided by 3 is 9? Well, if you know your times tables, it's 27 divided by 3. That's 9. And then finally, fill in the numerator of each fraction. So 7 is going to be the same as 7 over 1, 14 over 2, 21 over 3, 28 over 4, 35 over 5, or 42 over 6. All of those fractions are the same as the number 7. Just to finish, just to make this super clear why this works. So imagine you have 2. So 2 wholes. So that is 2 whole pizzas, let's say. So that's 2. Now I could split each of those pizzas into halves. So how many halves do I have now? Well, I've got 1, 2, 3, 4. So I've got 4 halves. So 2 is the same as 4 halves. I could also split it into quarters. So how many quarters do I have now? Say your answer to the video. How many quarters do I have altogether? I have 8 quarters. So 2 is the same as 8 quarters. I could split it into eighths. How many eighths do I have between my 2 pizzas now? How many parts do I have between those 2 pizzas? Say your answer to the video. I have 16. 16 eighths. So using the shaded shape idea that we've used previously helps to explain why you can write integers as fractions. So you can think of it as either top number divided by the bottom number, or you could think of it by actually thinking about shapes. I personally like to think about pizza because I like pizza, as I'm sure most people do. I hope this video was useful. Please make sure that you've marked and corrected your work for the independent practice. Please like and subscribe for more videos on Key Stage 3 Maths.